Take it away.
Hello all, my name is Chelsea Hill Essler, and today we are going to talk about linear programming, which seems much more daunting than it is, so bear with me. Okay, we're going to look probably specifically, depending on our time, probably just at maximization. Linear programming is used when the objective is to either maximize or minimize a linear function based on some constraints. Constraints can be either inequality constraints or non-negative constraints. An example of a type of problem that you would see using linear programming would typically be product mixtures. So what amount of A and what amount of B optimizes either to find the minimum cost or the maximum profit. So what we're going to do, also linear programming applications can help the seller determine that and make those decisions based on that. Okay. I'm going to show you how the formal model is set up, and then we'll go into graphing it. Just basic graphing, nothing specific. So when we're looking to maximize, we are looking at this as our what they call the objective function. So this is, product A, this is product B, we're looking to maximize it, and this is our objective. And it's going to be subject to some constraints. Okay, so these are going to be first our inequality constraints, which a basic one would be some production constraints. So this could be, we are only producing a certain amount total, or we're only producing a certain amount of one, or something along those lines. Really cool to get these out. And these again are inequality constraints. After that, we're looking at our non-negativity constraints. We're never going to make a negative amount of product, so we can never have that be an option. So this is going to go down here, and again, our non-negativity constraints. A problem with two inputs, typically we can graph to find a simple solution. If there's more than two inputs, we would want to use, or three we could use. It will just produce a 3D graph, so you're going to have a harder time interpreting it, in which case we can use something like Excel's solver program, and it can find the information and give us our, if there's an overage of one product, our surplus, or our slack, so if we don't have enough of them. But what I'm going to do is I'm going to just show you a basic graph of what it would look like. So right here, and this is going to be, again, maximization. We have second variable here, we have our first variable here. And here we're just going to be drawing some constraints. So these are just going to be basic lines of what the constraints could look like. So we have constraint 1, constraint 2, and constraint 3. Okay, so here we're going to have a few points where we're intersecting. And these are called our extreme points. And in the case of maximization, this is going to be considered, this is what I'm shading in right here, our feasible region. So any of these points could possibly be our optimal solution. So these are what we want to look at. And when we would want to graph the actual lines when we use these numbers that would be put in, it's going to be one of these that goes through the points. Okay, actually we have just a little more time, so I will show you, using this, what our minimum would look like. And in this case, we would want to change these, because the constraints are going to be to minimize it. So we are looking at, and in this case, it will be just the opposite of what we were looking at before. give you